All right, guys, here we go with the 1-7 video talking about the distributive property. All right, after this lesson, I should be able to use the distributive property to simplify expressions. Okay, in your favorite video game, you rotate shapes as they fall to make them fit together in a rectangle. When you complete an entire row, you score 1 point for each square in that row. The screen at right shows your latest game in pause mode. Using only the shapes shown, what is the maximum possible score for this game? Explain your reason. Okay, so one of the keys is I can only use the shapes that are shown in the picture. All right, and if I were to drop all these down, straight down, I would wind up with a 3x8 rectangle. Okay, I'd wind up with 3 high, and there's 8 going across. 1, 2, 3, 4, 5, 6, 7, 8 across. So it's a 3x8 rectangle, and obviously 3x8 makes 24 blocks, so I would score 24 points. All right. To solve problems in mathematics, it's often useful to rewrite expressions in simpler forms. Well, we've already looked at doing stuff like that. So the distributive property illustrated by this area model below is another property of real numbers that helps us to simplify expressions. So if you look here, what it shows me is that 8 times x plus 5, I could break that apart into 8 times x and 8 times 5. So the model shows me that 8 times the quantity, x plus 5, is the same as 8 times x and 8 plus 5 added together. Okay, that's what distributive property is all about. So I can use distributive property to simplify the products of a number and a sum or difference. So let's take a look. There's 4 ways that it could be expressed to you. So typically you would have a number stuck to a parenthesis with an addition sign, or a number stuck to a parenthesis with a subtraction sign. They could put the number in the back there, or the variable in the back. Most of the time you see it in the front, but don't get freaked out if it is in the back. And all you're going to do is a times b and a times c, so it's plus a times b plus a times c. Here, give away the single term to the 2 inside the parentheses, a times b plus a times c. And somebody would ask, does it have to be AB or could it be BA? Normally you'd write it alphabetically, but since we know multiplication, the order doesn't matter, you could write it BA, but like I said, normally we write it alphabetically. Here we'd have AB minus AC. Here you would have AB minus AC. All right, so some examples. Looking at the top one, if I give 4 away to 20 and 6, 4 times 20 plus 4 times 6. Likewise, if the 4 was stuck behind it, the single term was behind it, I'd give away the 4 to everything inside the parenthesis. All right, here's a 7 with a minus in the middle, so 7 times 30 minus 7 times 2. And same idea here, we just threw the 7 into the back. All right, so pretty simple. All right, problem number 1, simplifying expressions. What is the simplified form of each expression? So one thing we want to remember is that when we read one of these expressions, we would read it as 3 times the quantity x plus 8. So whenever we see a parenthesis there, we call that the quantity. All right, and what's in there, x plus 8. 3 times the quantity x plus 8. Notice the 3 is stuck right to the parenthesis, so that indicates a multiplication. So 3 times the quantity x plus 8, well, that's just really 3 times x plus 3 times 8. Which would just be 3x plus 24. Here in B, notice the single term is stuck to the back, but it's the same operation. I got to give the negative 7 away to both pieces. So that would be 5b times negative 7 minus 4 times negative 7. 5b times negative 7 is negative 35b. Negative 4 times negative 7 is positive 28. Okay, so there's a couple for you to try. So go ahead and pause it and answer those questions. When you're done, unpause the video. Okay? Well, welcome back. If you give the 5 away here, you'd wind up with 5x plus 35. I give the 12 away here. I had 12 times 3, which is 36. 12 times 1/6. 12 times 1/6 is 2. 1/6 of 12 is 2. So I would have 36 minus 2t. Negative y times 2y is negative 2y squared plus 1y, because I have a negative y times a negative 1. Negative times negative makes positive. I would have a negative 2y plus positive y. All right, so hopefully you got those correct. Problem number 2, rewriting fractional expressions. What is the sum or difference is equivalent to this fraction? Lots of times the fractions freak us out, but just remember fraction is really just division or multiplication times a fraction. So if we think of 7x plus 2 over 5 as 1/5 times 7x plus 2, right? Dividing by 5 is the same as multiplying by 1/5. Well, that's an easy way to see. Okay, I took this and I really made it a distributive property problem. So what you would see is that 1/5 times 7 is 7 over 5x, and then 1/5 times 2 is just 2 over 5. 1/5 times 7 is 7 over 5. 1/5 times 2 is 2 over 5. So 7 over 5x plus 2/5. So a couple to try. Let's take a look at them. So remember, dividing by 3 is the same as multiplying by 1/3. So 1/3 times 4x minus 16. Well, then if I just give away the 1/3, I'd wind up with 4/3 x minus 16/3. All right, here in B, well, if I break that into 1/12 times the numerator, right, numerator's the top, 1/12 times 15 plus 6x. Well, 1/12 times 15 is 15 over 12. 6x times 12 is 6 over 12x. I can simplify these, so I should. 15 divided by 12, well, I can reduce that fraction because 3 goes into both, and I'd wind up with 5/4, and 6 over 12 is the same as 1/2, so 5/4 plus 1/2 x. In C, if we rewrite it as 1/4 x minus 8 minus 2x, okay, because dividing by 4 is the same as multiplying by 1/4, and then if I just give away that 1/4, I'd wind up with 2 minus 1/2 x. Cool. Problem number 3, using the multiplication property of -1. What is the simplified form of this expression? So remember, when there's a negative sign in front of the parentheses, it means the opposite of everything inside the parentheses. So opposite, positive, negative change. So the opposite of 2y minus 3x. Well, the opposite of 2y is negative 2y, and the opposite of negative 3x is positive 3x. So the opposite of positive 2y became negative 2y, the opposite of negative 3x became positive 3x. Here I got to give away the negative sign to both. I'm taking the opposite of this. Well, the opposite of negative x is positive x. The opposite of positive 31 is negative 31. So real simple. The opposite of 5a is negative 5a, and the opposite of negative 4 is positive 4. So negative 5a plus 4. All right, we can simplify an algebraic expression by combining the parts of the expression that are alike, or we know those as like terms. So in an expression, a little vocab for you, a term is a number, variable, or product of a number and one or more variables. All right, they're the individual pieces. A constant is a term that has no variable or just a number. It remains consistent. It doesn't change. So it has no vary to it. It has no variable. And a coefficient is a numerical factor of a variable. That's just a fancy way of saying the number that's stuck to a variable. All right, so if we look at this expression down here below, we can see a couple of these things illustrated. So the terms are the individual pieces. Terms are always separated by plus or minus signs. So this is a term, this is a term, this is a term, and this is a term. All right, all the individual pieces. A constant is the number that doesn't change. So in this one, the 9 is a constant. There's no variable stuck to the 9. The 9 will always be a 9. And then the coefficients are the numbers that are stuck to any variable expressions. So the 3, the 2, and then the other 3 there. So the coefficients would be 3 and 2, 3 being listed twice. Okay? So some little vocab. Algebraic expression in simplified form has no like terms or parentheses. So my job is to combine the like terms. What's the simplified form of each expression? So 8x squared plus 2x squared. Well, since they're both the same, they're both x squareds, I can put them together. 8x squareds plus 2 more x squareds are 10x squareds. So that's pretty simple. Here we go in B. 5x minus 3 minus 3x plus 6y plus 4. I can only put in things that have the same exact last name. So x's can only go with other x's. They can't go with y's. They can't go with regular constants. So 5x minus 3x, those are like terms. -3 and 4. those are like terms. They're just constants. They're just basic numbers with no variable name stuck to them. And then the 6y doesn't have any partners. So if you just do the operations, 5x minus 3x, notice I took the sign with the negative 3x. So whatever sign is right next to the number is what he is. 5x minus 3x is positive 2x. Negative 3 plus 4 is 1. 6y doesn't have a partner, so he just comes down. You can write it in any order you want. Typically, the variables are written in alphabetical order, and the constants usually written at the end. But any form would be fine. Okay? So here's a longer one. So know that you can only put your x squareds together with other x squareds. X squareds don't go with x's. So 2x squareds can go with another 1x squared. Notice this is a 1x squared. So that would give me 3x squareds. I got a positive 5x. He can go with any other x's. So notice that's a negative 3x. Take the sign with you. Minus another x. So I got a 5x minus 3x minus one more x would leave me with 1x. And then I have a 7 and a 2. Those are just constants. They don't have a variable stuck to them. So I can add those together. So I have 3x squareds. I have 5 minus 3 minus 1 more made 1x. And I have 9. So 3x squared plus x plus 9. Again, any order would be fine. Normally, they would put the squareds first, then the regular x's, then the constants at the end. Okay? And then your job, my friends, is there's 3 more got it questions here. So I'd like to see how you handle those, and I'm going to look at those tomorrow. So A, we're combining the like terms. B, combining the like terms. And then C, they're asking you, can this be simplified any further? Explain why or why not. All right? So that's it for 1-7, distributed property. I'll see you next time. Peace.